This lesson is just reviewing the exponent rules that you should know from grade 10. So first of all, we'll remember the first three really quickly, and then the last two, the 4 and 5, we will go over the why behind those ones. If we're multiplying powers with the same base, so I have a base of x here, and the dot just means to multiply, the rule is you can write that as a single base, single power with a base of x, and then you just add those exponents together to get the new exponent. So for example, if you had like 5 to the exponent 3 and you're multiplying it by 5 to the exponent 4, that could be expressed as a single power of 5 to the exponent of 7. The 7 comes from 3 plus 4. If we're dividing powers with the same base, the rule is you're going to keep that base the same, whatever it is, and then you just subtract those exponents from each other. So that says m take away the n. All right, so for example, if I had 9 to the exponent 7, but then I'm dividing it by, and I forgot to actually make that a divide sign. That should be a divide sign there. Divided by 9 to the exponent of 5. The answer will be a base of 9, and then 7 take away 5 would be a 2. So that's how we write that as a single power. Power of a power, when you have an exponent outside of another exponent, the rule is the base stays the same, but then you multiply the exponents together. So for example, if we had 2 to the 5 all to the exponent of 7, that's going to equal 2 to the 35, because 7 times 5 is 35. All right, our zero exponent rule, if we have anything to the exponent of 0, the answer is just going to be 1. And the question is, well, why does that happen? Let's consider if we had 5 to the 6 and we divided it by 5 to the 6. The rule up above says that when we're dividing and the powers have the same base, you can just keep that base the same and subtract the exponents. So you would get 6 take away 6, which would be 5 to the exponent of 0. But let's just consider that for a second. If we have 5 to the 6 and we divide it by itself, 5 to the 6, any number divided by itself is going to be a 1. So any number divided by itself equals 1. So then we can conclude that, therefore, 5 to the 0 has to equal 1. So I've just added that in, but any number divided by itself is equal to 1. All right, negative exponent rule. Again, this would have been new last year, and the 2Ps, you may or may not have gotten to this last year. I'm not entirely sure where you were at, but let's just talk about that for a moment. Again, let's do this through division. Let's say we had 5 to the 6. Helps if I get the right pen here. 5 to the exponent of 6 again, just because. And I divide that by 5 to the exponent of, I just changed my mind. I'm going to use a smaller exponent here, just because what I'm going to do with it requires me to do a bit of writing, and I just don't want 6 factors of that. So let's talk about this here. We've got 5 to the 3 divided by 5 to the 5. If I use that dividing exponent rule, that's going to give me a 5 to the negative 2. Now let's consider this, writing this another way. That's the same thing as 5 to the 3 divided by 5 to the 5, which really means I have 3 factors of 5 on the top being multiplied together, and I have 5 factors of 5 being multiplied together on the bottom. And when we're multiplying and dividing things, it doesn't really matter what order we do that in. So I'm going to do this pair here. 5 divided by 5, that just becomes a 1. And then this 5 divided by 5 becomes a 1. And this 5 divided by 5 becomes a 1. And what I'm left with on the top is just a 1. And what I'm left with on the bottom is 5 squared. So that then means I can conclude that 5 to the negative 2 has to be the same thing as 1 over 5 squared. So that means if I have x to the negative m, I can rewrite that as 1 over x to the positive m. So I know when I teach this, sometimes I'll say, you know what, this is negative. It's not happy where it is. It needs a change. It needs to change the sign, but to change the sign, we're going to change the position. So right now, x is on the numerator of a fraction, we're going to slide that down to the denominator, and that becomes x to the positive m. It's now happy in its new position. Similarly, with this, I have 1 over x to the negative m. X is not happy where it is. It's negative with its exponent. It's going to slide up to the top and just become x now to the positive m. And then that would be over 1, but dividing by 1 is not going to change anything. All right, for this last one here, x over y all to the negative m, we can look at that as a couple different ways. That negative m exponent has to apply to everything in that bracket, which means I have x to the negative m divided by y to the negative m. The x and the y both are not happy where they are. They're going to change where they are. And that's going to become a y now to the positive m because it's happy where it is now, and the x moves to the bottom and it becomes a positive m. So those are just our negative exponent rules, and we often develop them further, but if you can work with the fact that it was true for the first one and just go with it for the second and third example here, then that would be great. We have example 1 here. Use the negative exponent rule to write each as an integer or fraction. And I thought we better practice this because this is the tricky one. All right, so if I have 4 to the negative 2, I'm looking at that very first negative exponent rule. I'm going to rewrite that. The 4 is not happy on the top where it is. It's going to slide to the bottom, and we have a 1 on the top just as a placeholder, and then the exponent becomes positive. So that gives us 1 over, and then 4 squared is 16. So that leaves our answer in a fraction form. Some of you will have calculators that will do that for you. Some of you don't have calculators that will do that for you. So you need to know that negative exponent rule. Plus, when we work with variables, you just got to know a rule. That's just the way it is. All right, 5, not happy. It's got a negative exponent. It's going to slide up to the top. It's going to become then 5 to the positive 3. And then 5 times 5 is 25, times another 25 is 125. And then this last one, I'm just going to write one more equals up here. This is the same thing as y over x all to the positive m. So that's a shortcut. I can just switch the positions of the x and the y and then change my exponent to be positive. So that's what I'm going to do here. I'm going to switch my position. My 3 slides up to the top, the 2 slides down to the bottom, and now that's a positive 4. And then both of those numbers get the exponent of 4. So 3 times 3 times 3 times 3 is 81. 2 times 2 times 2 times 2 is 16. And that won't reduce because 3 and 2 are prime numbers. The answer, there's nothing to reduce there. All right, hopefully that's making sense so far. Part D, the 3 is okay where it is. It has a positive exponent. It's going to stay on the top, but the 2 is going to slide up to the top, and the exponent on the 2 becomes a positive 5. Now I'm going to actually evaluate this. The bases are not the same here. I cannot combine that in any way. I'm going to have 3 times, and then 2 to the 5 is 32. And 3 groups of 32 should be 96, I believe there. 3 times 3, 9, 2 times 3, yeah, 96. Similarly, bases are not the same here. I cannot apply the multiplying rule. So I'm just going to go into evaluating and applying my negative exponent that is here. So 2 times 2 times 2, 2 times 2 is 4 times 2 is 8. And then I'm going to slide that 3 down to the bottom, and it has a positive exponent now. And I didn't move the 2 to the 3, which is 8, because its exponent was positive. It just stays where it is. It's happy there. And then 3 squared is 9, so that equals 8/9. On F, this one's not happy where it is. It's going to slide down to the bottom and become a positive 2 exponent, and that is going to join the 3 cubed by multiplying, and we need a 1 as a placeholder on the top of that. 4 squared is 16, and then 3 cubed is 27, so 16 times 27 is 432. I think I'll write those steps in there. 16 times 27 equals 1 over 432. All right, and our second example here, write the following as a single power first, so use the exponent rules, and then evaluate. Final answer should be integers or fractions. So you're going to follow order of operations. Order of operations says you've got to apply an exponent. So we've got power of a power that has to apply before we can do the dividing here. So the rule is we want to multiply those exponents together. So 5 times -2 is -10. And then we still have the divide by 3 to the -8. And then the rule is we're going to subtract those exponents when we divide. So -10 take away -8 would become a +8 here. And then -10 plus 8 would be -2. So if it helps you to write down the little step so that you don't make a mistake on the sign, that would be probably a good idea. Now I'm going to apply the negative exponent rule. So I never apply the negative exponent rule until I absolutely have to. I take care of all the other rules first. So the negative exponent tells us the 3 is not happy where it is. It slides to the bottom. The exponent is now positive. 3 squared is 9. That's going to equal 1/9. Moving along, looking at what I have here, I'm multiplying on the top, and my base is -2. So my base is going to stay at -2. My rule is I'm going to add these exponents. So 4 plus -5 would be a -1. Add, yep. And then on the bottom we have -2 to the -2. We're dividing, so I'm going to subtract those exponents. So -1 take away -2, that would be add 2. -1 add 2 is just 1. So that's going to be -2 to the +1, which is just -2. So it doesn't matter that the base is negative. You don't slide things around when the base is negative. It's only when the exponent is negative. All right, our base this time is 2/3. And I'm going to keep that base. I'm going to multiply these together. The rule is when I multiply them, the base stays the same, and we add those exponents together. So 1 plus 5 is 6. And then we're going to do the division. The rule is keep the base the same, but subtract the exponents. So 6 take away 8 will equal -2. 2/3 to the -2. That's an unhappy one. We're going to flip it over and make the exponent positive, and now we're going to apply that exponent. 3 squared is 9, 2 squared is 4. That's going to equal 9/4. All right, the last example here, use the exponent rules to write it as a single power. I have a power of a power that needs to happen before I can multiply. So I'm going to have x to the 5. It's going to multiply x to the -6. We're multiplying. The rule is keep the base the same and add those exponents. So 5 plus -6 will equal -1. And now I'm going to rewrite that with a positive exponent. So that's going to equal 1/x. We're going to evaluate that numerator here first. -4 add 2 would be -2. And then we're dividing, so -2 take away 3 would be -5. So that's going to equal a to the -5, which is 1/a to the +5. And the last example here, power of a power has to happen first. We're going to get y to the -10, and that's multiplying y to the +10. -10 add 10 would be 0, so that's going to be y to the exponent 0, which we know anything to the exponent 0 equals 1. So hopefully you are understanding all of that. If you have any questions, please feel free to email me. Let me know and I will help you out with that.